Alrighty, so before break we were talking about optimizing, and we're going to finish that up today real quickly, hopefully real quickly. So at your table, answer those two questions. So what is the first derivative of position called? Velocity. So velocity is that first derivative of position. What about the second derivative of position? We could also call acceleration the what? Not only the second derivative of position, but what?
First derivative of velocity.
Okay, the first derivative of velocity. And so when it comes to then talking about optimizing, we can start talking about things like minimizing and maximizing different aspects of these derivatives. And so that's kind of what we're going to focus on, is looking at motion from an optimizing standpoint. And it makes motion problems go a little more quickly. So let's just take this first row for an example. If I wanted to shoot something in the air and find its maximum height, am I trying to maximize or minimize anything?
Yeah.
What am I trying to do?
Maximize.
Okay, I'm definitely maximizing something, right? I say it right here. I'm definitely maximizing, and height is related to position. So I'm definitely maximizing my S of t. Well, if I'm maximizing my position, then what is true about the first derivative of that?
Maximizing your velocity.
Okay, so if we think about in this case, if we think about a projectile being shot into the air and then, of course, it's going to fall back down to the ground, what's true about this location at its maximum height here?
Zero velocity.
Okay, what's happening at that maximum height? It's got zero velocity. It's turning around. Zero velocity is also another way of saying what? Another way of saying what? Zero velocity is another way. If something has zero velocity, then it is at that moment. We could also say it's at rest at that instant. So, so what is true then about if we take the derivative of this and call it velocity? Then we know that it is what value? What's true about the velocity? Okay, so we know this is zero. Okay, so a maximizing, another word for a maximum is we could call it a hill, right? This is our hill. Let's make that a little tinier. So we could call this a hill. Okay, do we need to know anything about acceleration to solve this problem? So we don't really need to know this information. We can get it, but we don't need it. Okay? So at your table, try the rest of these. Try, setting up the conditions for turning around. Okay? And setting up the conditions for at rest. And how about maximum velocity? And how is that different than maximum speed? So go ahead at your table and try to set those up. Set those up as your table. Awesome. I agree. So the question is this really just a max or could it be a min? At rest. It could be a min, right? So I would say max slash min. In other words, yeah, exactly. It's an extrema of some sort, but we don't know which one. We don't care either. We just need to know where you're at rest. So sometimes it'll be a little ambiguous, and that's okay. Okay, how we doing? Turning around, what does it mean in terms of velocity? Think about it in terms of velocity. So what does turning around at rest mean in terms of velocity?
So turning around velocity.
Yeah, exactly. Does it matter which one it is? No, because of the only condition we have is we don't turn around. We don't know. Okay. Does it? Okay, so a lot of people are kind of coming to the conclusion that these conditions are really all saying the same thing about velocity. They're saying different things about position though. The first one was definitely a max. These next two, maxes or mins? Or doesn't it matter? Doesn't matter. So in fact, I see some people already starting to write just their generic term extrema. Okay, I've seen people do that already. In other words, it's a max, it's a min, we don't care. Okay, it's definitely a max or a min. But we don't care. What's true about the acceleration values? Do we need them? Nah. They could be there. We don't need them. In fact, at rest, we could definitely say, what about acceleration? Yeah, it really is. We're just sitting there. Okay, so now we're looking at terms that are specifically geared toward optimizing something else, those last two rows. I agree. No, speed is not. Speed is your speedometer. Think about your speedometer. It's not telling you what direction it's in, right? Velocity is direction. That's your navigation. So they're gonna have two different things in terms of optimizing velocity. That still isn't working.
Because just where it starts.
Can you have somebody airdrop it to you?
Oh, I was saying.
Totally agree. How is speed different than velocity? What does that say? Velocity. You want to maximize velocity.
Yeah.
Okay, yeah, if you're thinking about free fall, okay. Yeah, I agree. It's the fastest as you release it, then it slows down, snaps down, stops, turns direction, speeds up. And then it's going just as fast as So think about what that means on our velocity. That's position, right? What I just drew in here was position. So if you think about that, you think about velocity, it's the fastest upward here. So our velocity graph is fastest, right? Slowing down when you stop about that axis. speeding up in a negative direction. So where's my maximum value on that graph? Beginning, middle, end, beginning, right? This is also a very fast value, but it's from a real number perspective, it's actually the smallest value. Does that make sense? So where's my velocity maximum? Okay, and so are we looking for a hill, a valley, or does it matter? A peak, a valley, does it matter? Now we have to kind of extend this to something more than just football. So we're speaking up this one, down, this one, down. It's not just free fall now. So my fastest speed is actually it's like
It's like a weird.
yeah, it's
My car.
I've seen a couple of tables already get started on this max velocity. Do we care anything about position? No. So we can literally say, all we really need is to look at the velocity graph. Maximizing my velocity means what? Oh, well, not necessarily. Think about maximizing my height. What did that mean to my position function? What was I looking for? Okay, so maximizing velocity, I've got to look for the same thing, but on what function? On the velocity function, exactly. Rats.
Whoa.
That I did not mean to do. Wow, I'm still doing that though. So if I didn't realize that wasn't locked. There we go. So if I take that information and put it down here, because maximizing is maximizing. I'm just maximizing a different function now. I want to maximize my velocity. I want to find my hill on my velocity, my peak, so to speak. Okay? But what does that mean about acceleration? Well, not just a constant. If I'm finding a hill on my velocity function, what's my tangent line at that hill? 0. So I've just really taken the conditions for maximizing height, right? Find a hill, take the derivative, set it equal to 0, and I've shifted those things. I've shifted those conditions over one function. Now I'm finding my hill on my velocity function, which means I'm taking the derivative of that, setting it equal to 0. That first derivative test. And as people were writing on their charts, that test for relative extrema. Okay? Now, how is that different than speed?
Max it.
Speed is a max and a min, because speed is what?
It's absolute.
Yeah. Speed is your speedometer, right? Does your speedometer tell you what direction you're moving? No. Your speedometer just tells you how fast you're going. Okay, your navigation tells you your direction. So if that's just telling you how fast you're going, then I can take a peak or a valley. It doesn't matter. So I can take a max or a min. So I have this scenario. Here. And either way, if I have that scenario here, what's true then if I'm looking for either hills or valleys? What's true about the derivative of the velocity function at a hill and a valley? The derivative of the velocity function, notice I'm saying derivative of velocity function and I'm writing acceleration because it means the same thing. At a hill and a valley is 0. Okay? So we can really approach, and the homework really for tonight is to just do this, just to optimize whatever function it is they're asking you to optimize. It might be position, it might be velocity. Okay? Now, this is where you kind of have an advantage over other schools in that physics at this school is a graduation requirement. You got to take it. So we can actually ask you a little bit about speeding up and slowing down. So actually, when I thought about this, the last class period, I thought I probably should have gotten rid of this line because we're going to kind of talk about two very specific situations here. So I'm going to get rid of that line. Speeding up means what? What does it mean on your speedometer? Speeding up means your speedometer is going which way? Are you going from 0 to 60 or 60 to 0? On your speedometer. Okay, you're getting faster and faster, right? Slowing down means what? You're going from 60 to 0. Okay, it means you're, well, this is a little redundant, but you're going slower and slower. What does that mean in terms of velocity and acceleration? If you're speeding up and you have positive velocity, what type of acceleration do you need to make that positive value get more positive? You need positive acceleration. So this comes into, remember when we were doing the charts and we were testing on either side of the critical points? So now we've got to test, if we find a hill or a valley, we've got to test on either side of it and say, is my velocity positive? And is my acceleration positive? And then I'm speeding up. What if I have velocity in the negative direction? How can I make that value more negative? Because that would be going faster in the negative direction. What type of acceleration do I need now? I need negative acceleration. So in other words, those signs have to match. What if I have positive velocity and I want to slow down? How do I chip away at that positive value? With what kind of acceleration? With negative, yeah, an opposite sign. I can reduce that velocity by having negative acceleration. What if I have negative velocity? How do I get that value closer to 0? In other words, if I'm here at -8, how do I get this -8 closer to 0? With what sort of acceleration? A positive change, exactly. So here we have not matching or different signs. So there's where our tests come in on either side of our critical point. So we'll find a hill or a valley, and then let's say we find that hill or valley at 2 seconds. Maybe we test 1 and 3 to see where our velocity and acceleration signs are. Does that make sense? Okay, tonight's web assign though really has to deal with the top part of this chart of the optimizing. So if we look at the next page, and I'll flip to the next page in a few minutes, but I can just go through it if you want to flip to the next page if you're at that point in Notability. We have a layout really of the rest of the semester. So this week we'll do section 5 tomorrow and section 6 on Wednesday. And those will go pretty quickly. The last day of the week is kind of finish section 6, start reviewing for the chapter 4 test. Monday is also reviewing for the chapter 4 test. And then Tuesday, week from tomorrow, is the chapter 4 test, the early testing date. Okay. And I'm not quite sure, I know I have CAF there, but we actually can't use the Commons for that. So I'll have to find a home for us. I'm not sure we can use the library either because we're map testing next week. So if you know that early test date will be based on your completion of your proficiency checks. So we'll have another proficiency check for section 4.5 and 4.6. So those will be the big three. And so as your name goes up there, you know you're checked off. And I haven't checked off people yet since break, so I have to update that. And then next week after the test, we'll have a day just to get together. I'll give you a semester review packet. And then the end of next week will be that incentive day. So if you hit the early test date, you're off on that Friday of next week for this class period. If not, then that's when you'll be taking your test. And then that following week is exam week. So we'll come back, we'll have a couple more days of review, and then we'll hit that exam at the end of the week. Okay, so any questions about that?
Do you know if we're having an exam schedule?
Yes, we
Your,
To my knowledge, we are having an exam.
Yeah, right now, like I had like.
To my knowledge, we are going to have one. I'm not sure what the the structure is, you know, like, I know that the colored days are still gonna be our colored days. You know, no. Like, you know, we meet Monday, Tuesday, Wednesday, Friday. So, although it's only a 4-day week because, you know, classes don't meet on Friday. So we would meet like Tuesday, Wednesday, Friday. Right? 1 hour class periods. So I know we're gonna still be meeting on the days. And that's gonna be Monday, Tuesday, Thursday. You know what I mean?
so it's not really an exam schedule?
Well, there is. There's timings are different. It's like we're compressing some classes and then we're expanding some other hours.
So like
So I'm
different
not-
days, one have a long class and
Right.
they have a short class.
I don't know. I need that. And I'm trying to get that. So this is a step in that direction. It's not, yeah. Well, I don't think it's pressure from college. I mean, that's my personal opinion.
What?
Clean my room.
Not having exams.
Yeah.
You need a report.
Yeah, I have to make my bed, and then I would just throw my clothes in the drawer.
Well, and then by not having an exam schedule, then trying to make an exam schedule out of a non-exam schedule,